All right. I think it looks like we're recording. Great. Well, welcome everybody. Thank you for attending our first networking webinar series focused on industrial networking. This will be our design webinar. We do have two more coming up in the series. The next one is on security. That is September 22nd. And then if you have signed up for the managed services webinar, which is our third and final one in the series, we did have to change the date from September 29th to October 6th. So if you signed up for that already, we'll send out the updated information and links. If you have not, just be aware that we're going through and changing the date to the 6th. So with that, I'm Chad DePasquale. I work for HESCO, and I'm the Vice President of Services. And we're lucky to have Steve Hartsfeld here from Rockwell Automation. He is the Business Development Lead for Connected Services. And today he's going to take us through how to design your networks, what to consider, and then at the end, maybe some ways that HESCO and Rockwell can help if you do get stuck. Just a couple shout outs here. If you are interested in signing up for any of the other networking webinars, we also have two more safety webinars. One of them is coming up today on machine safety. You can go to our website at hesconet.com and just hover over the training button. And from there, you'll be able to see which webinars we have and sign up right for them right on the site. And then last, we are recording this. We will send you a link out to the video once it is done and complete. And at any time, you can go to YouTube and Google, or search, I should say, for HESCOnet, that's N-E-T. You'll see our YouTube channel, and we also post those videos on there. What's nice is you'll be able to see this video and then any of the other videos we've had in our previous webinar series. So with that, Steve, I will hand it off to you, and thank you.
Thank you. Good morning, folks. And thanks again, Chad and Angela at HESCO, for having me today. I'm looking forward to talking to everyone this morning. Let me introduce myself very briefly. Like Chad said, my name is Stephen Hartsfeld. I work for Rockwell Automation in our connected services business. I've only been with Rockwell for a little over 3 months now, but I've been involved with industrial automation in some way, shape, or form for the last 12 and a half years, over which time held some network-related certifications from BICSI and multiple Cisco CCNAs. I currently reside in a very fall-like central Pennsylvania, in fact, in the sweetest place on earth, Hershey, PA, with my wife and our 2 sons. So today I'm going to talk to you about industrial networks and some of the things to take into consideration when designing those networks. So who are we as Rockwell Automation? Very briefly, we are a global company doing business in over 80 countries with over 23,000 employees and almost $7 billion in annual sales. And in fact, Rockwell is the largest company in the world dedicated to industrial automation. We've been helping companies deploy control networks for many, many years, ultimately striving to help them bring the connected enterprise to life. So over the next few slides, I'm going to talk about something called CPwE, what it is and why it is important. But first, I think it's critical that we identify what we're trying to achieve with CPwE. And these are 3 big ones, right? We want to enable agility in your businesses by increasing connectivity and interoperability to securely connect disparate data sources, of which there are many, to leverage that data effectively, which is to say that we want to derive insights across the enterprise. We want to, of course, optimize production yield by connecting operational and business systems for complete end-to-end visibility and control of our operations. And throughout all this, we want to minimize our risk. We have to protect our physical and our network assets, our intellectual property, our data, and above all else, our human resources with a comprehensive safety and security architecture. So without even beginning to consider the strain that the coronavirus pandemic has placed on global supply chains, including manufacturing, there are a number of market pressures putting profitability and productivity at risk for manufacturing companies. First, there's been rapid globalization, which has opened up new opportunities. In fact, $25 trillion in GDP growth had been attributed to globalization from 2000 to 2016. And this in turn has led to a highly competitive marketplace. Industrial operations are always struggling to increase product output, work productivity, and cost efficiencies to keep up with global demand, but are hindered by aging infrastructure. 87% of manufacturing executives report that aging infrastructure impacts their operations. Another significant challenge in today's market is the increasing number of security risks and threats. Cyber threats and attacks can result in extended periods of downtime, compromised intellectual property, the loss of millions and millions of dollars in revenue. In fact, roughly 28% of manufacturing organizations reported a loss of revenue due to security attacks in the last year. To add to these challenges, the continued influx of data from a growing number of industrial IoT or Internet of Things devices, which is expected to have grown to 3.2 billion devices this year. And it's apparent that the existing and aging infrastructures just can't cope with it. So digital transformation through modernization is needed, but modernization is complicated and it must address numerous pain points. For example, aging infrastructure has resulted in proprietary networks and services, and that has increased network complexity. Cybersecurity in the current network infrastructures has not been robust enough to mitigate newer and more sophisticated attacks. As we saw in the previous slide, security threats can really compromise operations. The scale and volume of data is ever increasing, but data historically has been difficult to capture and manage. There's a skills gap currently where the traditional OT workforce is not ramped up for IT network implementation, management, and maintenance. And there's a need to provide the appropriate training and educational resources to meet that need. There's also many potential solutions in the market, and choosing a solution that addresses these challenges can be pretty overwhelming. So any solution that you choose must also be able to handle the volume and scale of data being generated through the introduction of IoT devices and the migration of OT to IT. So in order to address the need for this transformation, Rockwell forged strategic partnerships with HESCO and Panduit. HESCO is a trusted leader in the networking field and develops groundbreaking network and security solutions. And Rockwell's expertise in the manufacturing space makes the strategic alliance between the two companies ideal for developing technologies and techniques for modern manufacturing companies and for developing content that's relevant to both OT and IT personnel. Panduit is a leader in the physical infrastructure space, both for IT and OT applications, including physical media, cable management, grounding and bonding, enclosures, among many, many other things. Rockwell's strategic alliance with Panduit ensures that Panduit's industrial products, which we leverage in our physical network designs and implementations, are optimized to meet and exceed the requirements and challenges presented by the plant floor environment. So one of the key outcomes from these strategic partnerships is a holistic blueprint for digital transformation called the Converged Plantwide Ethernet, or CPwE. CPwE is not only a network architecture framework that we use in our own manufacturing facilities, but it is also a collection of reference documents designed to help industrial users develop and deploy the variety of network protocols and topologies used in OT networks. It's the products of years and years of ongoing collaboration between these three companies. And the proven reference architectures are a collection of architected, tested, and validated designs that help prepare industrial operations for the future by helping to enable business agility, optimize production, and minimize risk, like we alluded to earlier. So these can help customers to reduce their costs by simplifying designs, enabling quicker deployment, reducing risk, and deploying newer technologies from which many industrial users have traditionally shied away. And finally, it enables and encourages collaboration and convergence between OT, and IT by bridging the gap between industrial operations, operational technology or OT, and traditional IT with reliable and secure industrial IoT architectures that are readily actionable for OT personnel and will be easily understandable for IT professionals and will earn credibility with those folks as well. So this diagram illustrates that CPwE simplifies network design by connecting industrial operations and business systems together in a way that's seamless and secure. The seamless connectivity is achieved through the use of open systems that adhere to regulatory standards which enable flexibility and scalability. And proprietary systems can now be integrated without the need for wholesale rip and replace projects, thereby preserving the investment in the infrastructure and clearing the way for further innovation. And one of those key innovations is the ability to leverage IIoT or Industrial Internet of Things data from smart devices in industrial operations. So with CPwE, you can now build a common architecture framework that makes the network data ready and provides you with the tools to effectively transport, store, manage data for those key business insights. And when we say that we can integrate these using open systems, what we mean is that we've taken all the different areas and aspects of a plant and allowed them to communicate on a common open protocol. And for Rockwell, that's Ethernet IP, which is just the implementation of SIP, or the Common Industrial Protocol, over standard Ethernet communications. Whereas in the past, you might have a building network, an I/O network, a drives network, a safety network, and on and on and on. Those systems now can share a common platform, which dramatically lowers the total cost of ownership of these systems by making them easier to maintain, easier to operate, easier to troubleshoot, and easier to scale as your business grows. Now, this diagram is a representation of CPwE and is a summary of everything you can do with the CPwE, but it is also an example of an IIoT architecture for the connected enterprise, or for smart manufacturing, or for Industry 4.0, however you want to refer to the digital transformation that's occurring within manufacturing. It provides for that reliable and secure connectivity, as well as resiliency down into the industrial operations space for our most demanding applications, whether they're process applications or distributed motion over Ethernet, robotics applications, safety applications. We provide the documentation via the CPwE to make IT/OT convergence and the connected enterprise a reality. And it's not only a technological convergence, it's also a cultural and organizational convergence, which is important to consider. So what does that mean? What does that look like? One of the main tenets is the sharing of engineering best practices between control systems engineers, OT, and network engineers, IT. It's the standardization of designs and technologies that we can achieve using these reference architectures and models, as well as industry and technology standards. Excuse me. So CPwE helps address some of these issues that come along with your typical IT/OT convergence. For example, technology differences. IT and OT traditionally use different software and hardware tool sets. Varying implementations of layer 2 and layer 3 network services often create incompatibilities in availability, in performance, in security, and types of traffic. And on top of all that, there's typically disagreements in things like network access control and security policies and resiliency standards. But perhaps most important are those cultural differences that must be addressed. Acceptable service levels and response times are often starkly different between IT and OT. IT SLAs or service level agreements are often expressed in terms of hours or days, while OT requires recovery from issues in minutes or hours. When the line goes down, it needs to be up immediately. If the email goes down, maybe I'll just go drink a cup of coffee for a half an hour. It's not quite the same degree of urgency, right? policies and priorities are very different. You know, IT has traditionally followed a CIA model: confidentiality, integrity, availability, in that order of precedence. OT flips that model inside out, instead choosing availability and uptime as the most important aspect, followed then by integrity and confidentiality. Prioritization in QoS, or quality of service, is also handled differently. IT often prioritizes voice and video traffic on the network in order to provide the best possible user experience within those technologies. They want your phone calls to sound good, and they want your streaming, you know, your MS Teams calls, your Zoom calls to look good. In an OT network, voice and video, with some rare exceptions, are the lowest priority. Instead, with control and safety and motion sync traffic getting to the head of the line. And not to be overlooked is a skills gap in this space. Modern manufacturing demands a workforce that includes OT personnel with knowledge of IT skills and requirements, and IT personnel with knowledge of OT skills and requirements. And these industrial IT personnel are few and far between, and they're extremely sought after in this day and age. So over the years, as we have continued to develop these frameworks, we've driven out some key tenets. We want to leverage smart IIoT devices. We want to practice segmentation or zoning. We want to use a managed infrastructure in our switching and routing. We want to consider resiliency, both logical and physical resiliency. We want to consider time-critical data. We want to determine how wireless and mobility play a role in your operation. We always want to practice holistic and diverse defense in depth security, which states that no one single method or technology is perfect, but working together, many different approaches and tools can combine to create a much more secure environment. And convergence ready. We want our networks to be ready to converge with IT networks, as well as ready to converge with new areas or zones that are added to the network and expansion projects as your business grows. So understanding those tenets and also the technologies that can be used to address them is critical to the industrial network design methodology. Excuse me. First, it's critical that you fully understand the application and all of the functional requirements when you're going through a network design. What kind of devices are going to be connected to the network? Are they smart industrial devices or IoT devices? Are they non-industrial sensors or tools? How do these different devices communicate? What kind of protocols do they use? You know, what are the data requirements for those three priorities that we talked about earlier: availability, integrity, and confidentiality? What do the communication patterns look like? What devices talk to what other devices, and how do they need to do it? Does a particular bit or byte need to travel to a centralized server or even a cloud server, or can it be handled closer to the edge, thereby requiring less upstream bandwidth? What are your topology and resiliency requirements, and how are they impacted by the criticality of different parts of your operation, as well as the physical realities of your facility and your manufacturing process, right? What kind of traffic do we have to plan for? Is it just information and control traffic, or do we have safety? Do we have time sync? Do we have drive control, voice, video, on and on? We must understand these things in order to effectively design our networks. And once we get a handle on those aspects, we can begin to develop a logical framework which will define our segmentation or zoning approach. And zones are simply smaller, connected local area networks that break up the network from being one big flat domain into smaller sections that serve to protect against failures or breaches bleeding out of one zone and causing issues across the entire system. Now, one thing I actually want to take note of on the previous slide is the three different examples of cell area zones in this diagram. And those are the three kind of square-shaped zones on the bottom of the screen. These three zones in this example have differing degrees of resiliency. On the right, there isn't much need for resiliency, so we've gone with more of a linear approach. In the middle, there's enough need to warrant deployment of a device level ring topology that can withstand a single link fault. And on the far left, there's a PRP topology or parallel redundancy protocol topology that utilizes separate and unique LANs, and also redundant star that can withstand multiple link failures without impacting operations. So determining what degree of resiliency your network requires is one of the key decisions that you have to make in designing your own industrial control network. For example, any processes that represent bottlenecks in your operations should probably have some degree of resiliency built in, because if that section of the plant goes down, other areas can't operate. They might be starved of product, whatever the case may be. A packaging area that only needs to work in batches, on the other hand, might not require a high degree of resiliency built in. So once you have your logical framework developed, you can start to overlay it into a physical framework. A logical framework doesn't care what type of media you use, where the cables are routed, how much EMI or electromagnetic interference you're going to encounter, what the environmental situation is, whether it's heat or cold or corrosion or dust or vibration. Pardon me. It doesn't care where the network devices are going to reside. All a logical framework cares about is that device A connects to device B and device C and device D, right? The physical framework takes into account that this one part of the network is a half a mile away from everything else. So it needs a fiber connection instead of a copper media connection. It takes into account the footprints of your buildings, the harshness of the different environments, and that these particular subset of links require extra secure connectors and high flex cabling due to extreme vibration, just for example. An overwhelming majority of network related issues are caused by physical infrastructure failure. Cabling, termination, interference, and on and on. You want to design as much of that vulnerability out as humanly possible. And once you get to that point, you're going to deploy a holistic and diverse defense and depth security model. Let me repeat that because it bears repeating. Once you get to that point, you're going to deploy a holistic and diverse defense and depth security model. For many years, there was a sentiment within manufacturing organizations that in the absence of some highly concentrated and highly valuable piece of intellectual property, there was simply no reason that anyone would want to conduct a cyber attack on an ICS or industrial control system network. What could I possibly have here that some hacker would want or even know what to do with? I've heard this on multiple occasions over the years. And on top of that, for many years, it wasn't understood how to maliciously impact industrial devices like PLCs. Now, unfortunately, a couple significant events over the past decade have completely disproven these notions. The first of which being the use and subsequent discovery of the Stuxnet malware. Now, Stuxnet was a piece of code that was successfully planted to attack a completely air-gapped network, which was another previously thought to be best practice that was debunked. A completely air-gapped network of PCs, PLCs, and VFDs that happened to belong to the Iranian government for the purpose of enriching uranium for completely peaceful energy generating purposes. I swear we're not trying to build nukes, Mr. UN Inspector. Please believe me, sincerely, the Iranian government. This showed that not only that air-gapped networks are absolutely vulnerable, but also that industrial devices like PLCs and drives could be adversely impacted by cyber attack. Now, the second major development is the advent of ransomware. Ransomware, as I'm sure you've seen or read in the news, is malware that takes away the victim's access to his or her own system or information for the purposes of collecting a ransom payment. Usually this involves computers on the network having their entire drives encrypted with the only hope of recovery being cryptocurrency payment to some faceless hacker's Bitcoin wallet. And this is really big because it means that you no longer have to possess something of value to an attacker. The attackers have become smart enough to know that your information and your system is critical to you. And if they take those away and threaten to irreversibly destroy them, they could really impact your ability to be productive and to do business. Ask the shipping company Maersk or the oil giant Saudi Aramco, both of whom are the major players in their fields, and both of whom have suffered dramatically debilitating malware attacks. It took them offline for days, if not weeks, and cost hundreds of millions of dollars. You may be able to deduce that I really wanted to hammer home that point. So defense in depth, as I alluded to earlier, is the idea that a collection of mitigating techniques, each with their own shortcomings or blind spots, that are deployed together, is far more effective at preventing attacks as well as mitigating damage when attacks do happen than any one single tool deployed as a silver bullet of cybersecurity. That silver bullet does not exist, by the way. A good home security system, for example, consists of gates and cameras and sensors and doors and locks meant to hinder someone's ability to gain access and to continue to gain more and more access. You can't just build a wall around the house and hope that no one ever gets past it, giving them unfettered access to everything inside the walls if they did. And ultimately, what we're trying to do is reduce risk, simplify design, is speed deployment by using IT and OT standards, reference models and architectures, and precisely why the CPwE exists. So, if we look over in the upper right, we're talking about avoiding network sprawl, and I want to poll the folks that are on the call here. Can anybody tell me what network sprawl is and why I might want to avoid it? Who can be fastest on the unmute? Going once. Going twice. All right, so network sprawl is the organic growth of a network over time. The network starts off small and simple, maybe just one machine or one line or a subset of those. And as more and more Ethernet devices are added, more switches are daisy chained, more things are hung off the network, it gets less and less reliable and exponentially more difficult to troubleshoot, to maintain, and to manage. And to avoid this, we want to ensure that any architecture change is done with a specific purpose in mind. And we've taken steps to ensure that the rest of the infrastructure can support it. The 5-stage model in the lower right is what you want to be paying attention to there. First, you have to assess the current state of your network. Honestly, get an honest look. Then you plan for what it is that you need to do. You need to do now, what you need your network to do now, and in 1, 3, 5, 10, 20 years, and design a solution that meets those needs. You implement the design, you audit what you've deployed, and then you continue to manage and monitor the system until it's time to do it all again. So those reference architectures I've mentioned repeatedly, what exactly are they? These are basic blueprints for baseline architectures, considerations, best practices for design and deployment. Some examples of reference architectures in a completely different space altogether, like marketectures, which are high-level marketing frameworks and designs. They might be white papers or knowledge-based articles based on proof of concept testing. It might be in the form of like an accelerator toolkit, of which Rockwell has several, like Integrated Architecture Builder, for example. And of course, CPwE architectures, those architected, tested, and validated designs developed in the test labs of HESCO, Panduit, and Rockwell, made up of white papers, design guides, implementation guides, application guides, validated designs. There's simply too many things to consider during your network designs to go it alone, completely off the cuff without help. So I strongly recommend leveraging these assets and not reinventing the wheel. One of those key tenets that we mentioned earlier was a managed infrastructure. It's really important to build your infrastructures around managed switches. And this is not to say that there isn't a place for limited use of unmanaged switches, because there is. But let's take a look at some of the pros and cons of each of these, right? So with a managed switch, you're going to have built-in loop prevention and resiliency protocols. You're going to be able to do some segmentation like VLANs or security groups. You're going to have security services that you can leverage. And then, the management services like DHCP per port, where you can serve up an IP address to a particular port. DLR, device level ring, that topology that can withstand a link failure and still maintain communication to all of the resident devices. You get diagnostic information in a managed switch, so it can tell you what's going on inside the switch, what's going on the network. This switch's utilization is high. There's an issue with this particular port. It's really helpful for troubleshooting. And those prioritization services that we talked about earlier, that quality of service, making sure that that the data is prioritized properly. Now, on the downside, these are higher value components, right? There's more to them. There's more technology, and you can get more value for your organization out of them. So they are a little bit more expensive, and they require some degree of support and configuration to start up. Now, unmanaged switches, on the other hand, they can be pretty cheap, right? They're inexpensive, and they're simple to set up because there's not a whole lot to them. So you can pretty much take them out of the box, hang them on a rail, put some power to them, and start plugging up and off and running. But they don't have the ability to do any of the loop prevention or resiliency. So you could be experiencing loops or broadcast storms on a completely unmanaged network. There's no ability to set up security services. You can't do VLANs, you can't do quality of service, and there's no diagnostic information. So an unmanaged switch can't tell you what's going on with its ports and with its own internal to the device, which makes troubleshooting very, very difficult. And then beyond that, we have a number of devices, especially from Rockwell, that utilize ODVA embedded switch technology, which is a simple embedded switch inside the device itself that allows it to do some of the things that a managed switch can do, right? Whether it's that loop prevention or resiliency, quality of service, time synchronization. It can provide you with some of those network diagnostics as well, just like a switch, and it can help you, especially with things like linear topologies or ring topologies. It can help you simplify your cabling, which is that's a big area of cost when we're deploying networks. So can help keep things simpler and reduce cost as well. So one of the other key tenets that we talked about is zoning or segmentation. And zones are simply smaller connected LANs or local area networks, and they help for minimizing or controlling network sprawl. They offer us a modular approach for scalable and future-ready network infrastructure. And we might use them to segment IIoT technologies or security groups, and they help create smaller layer 2 broadcast domains because they restrict the flow of layer 2 broadcast traffic throughout the network. And they can create smaller failure domains as well as smaller domains of trust. Now, there's a few ways that we can achieve segmentation. We can use logical zoning by following geographical and functional organization of our devices. We can do some segmentation using a SIP bridge, for example, where we might have multiple network cards in a single PLC chassis, for example. We definitely want to leverage the campus network model with a multi-tier switch hierarchy using layer 2 and layer 3 switches. VLANs or virtual local area networks with access control lists and firewalls are a very important strategy. And we might use NAT or network address translation, where we have multiple identical machines, for example, or where we might want to only expose certain devices on a machine up to the larger plant network. And there are things that we can do now with software-defined networking group segmentation as well. So this is an example of how you might decide to segment your network. You have a data center, your data center at the core. You have site-wide operations or control center a level below. And you have your different manufacturing areas like processing and packaging segmented into different zones. Now, another key tenet we mentioned was convergence ready. And convergence ready just means that you develop an architecture that is ready to accept growth and can easily scale as your business grows. So this might mean that not only is your existing infrastructure convergence ready, but also that you mandate with your OEM and machine builder partners that they engineer their systems network in such a way that it's ready to converge with your plant-wide or with your site-wide system. So to circle back, the key tenets of CPwE and of any quality ICS network deployment, we're going to use smart IoT devices that enable Ethernet IP, that are physically hardened and able to withstand the industrial environment, and that they conform to industry standards. We're going to leverage a managed infrastructure that ensures resiliency and security, as well as providing those really valuable diagnostics that help to troubleshoot and maintain the network. We're going to do zoning and segmentation. So creating a logical model based on standards, physically segmenting when necessary, developing a layer 2 and layer 3 switch hierarchy with VLANs and firewalls and perhaps software-defined networking where possible. Resiliency, you must have a robust physical layer. Deploy redundant paths with resiliency protocols like DLR, Ether channel spanning tree, PRP, that parallel redundancy protocol, and use redundant switches and firewalls and wireless where applicable. Time critical data. Prioritize your data with QoS or with quality of service to ensure that your most important packets arrive on time and intact. And leverage time sync protocols like SIP-Sync for high-speed applications to keep everything aligned. And one of the nice things about the Stratix switches is, depending on the model, they come pretty much out of the box with a base QoS prioritization framework already deployed. So it's optimized for use in an industrial environment, knowing the types of traffic that it's going to experience, knowing which ones are typically most important. Something that an off-the-shelf Best Buy switch certainly isn't going to do. We want to leverage that wireless and mobility where appropriate, but I'll warn you that while wireless data consumption is great and wireless walk in the plant with an iPad that's got a dashboard on it is great and it can really enable you to do some cool things, wireless control should be handled with extreme care. When we're spinning motors, there's a lot of different factors in the industrial setting that can impact wireless signal performance. So handle wireless control with extreme care, and in my personal opinion, avoid it unless it's absolutely necessary. And there are times when it is necessary. And a holistic defense in depth security posture, as I mentioned earlier, with multiple layers at different ICS levels, with different technologies implemented by different roles. Okay, and be ready for that secure and effective convergence with your enterprise IT infrastructure. So where to find some of this collateral? This is simply a high-level visualization of the collection of architected, tested, and validated designs from CPwE. It isn't just one thing, right? We're constantly working to develop more content that can be used for exactly what we've been talking about, effectively leveraging all the technologies that are out there to enable agility, to optimize yield, and to mitigate risk. In fact, we're on our 16th release within the CPwE at this point. So everything you see here shown in red is existing collateral, and in blue are things that have been recently published, and everything shown in green is a continuous work in progress. So as you can see in the middle, the baseline document itself is in constant development and improvement. And on this slide in the deck, which you're all going to receive after after we get done here, are links to the CPwE content that really is a huge help in deploying an ICS network effectively. And if you decide that your company doesn't have the resources or the skill sets to undertake all the different aspects that I talked about, maybe it is simply too far outside of your core competency, whatever the case may be, Rockwell can help. Rockwell and HESCO together especially can help with a portfolio of network services. So you look back at that 5-step model. We start with assessing the network to see where it can be improved. We're using established CPwE standards as a benchmark. We can design some or all of your network for you, developing a topology, both logical and physical, and providing all the necessary documentation to make the design a reality. We have vast experience in implementing those designs. We've leveraged our experience implementing our own manufacturing networks and our strategic alliances to lead your deployment of logical and physical designs, to do the engineering, the procurement, the commissioning, the testing, the documenting for you. Those designs and implementation services also extend into the IDMZ, or industrial demilitarized zone, which is an industry standard technique for segmenting between OT and IT networks, between the plant floor and the enterprise. And once these systems are deployed, we can provide valuable network management services like 24/7 monitoring and administration, warranty management, firmware upgrades, network configuration changes, and more. So if you're interested in learning more about any of these services, please don't hesitate to contact me or your Rockwell account manager, or definitely the folks at HESCO. So with that, I'd like to open things up for questions. Feel free to ask, but also feel free to contact Chad from HESCO or myself after this call, so we can have a more in-depth conversation about your needs in this space. And when we do get this deck sent out to everyone, there are a bunch of additional slides that I've included that talk more in explicit detail about those key design tenets, and specifically a series on segmentation and what the different segmentation techniques we talked about look like in practice. So with that, I'm happy to open up the floor for any questions or comments or discussion that we might want to have. I finished a little bit earlier than I thought, so we got a little bit of time.
Steve, that's great. Thank you. Appreciate that. And if you do have a question, just unmute yourself. I see we have everybody on mute, or feel free to chat it in. I'll be taking a look at the chat, and then I can serve those up to Steve as well.
Yeah, definitely. And if if we don't want to hop in front of the group, please, by all means, don't hesitate to contact Chad. Don't hesitate to contact myself. Chad knows where to find me, so don't hesitate.
Great. While we're waiting for some possible questions, Steve, I think you said the CPwE is going to be linked in the slideshow that we're going to be sending out to everybody?
Yep, that is correct. Let me slide back to that one.
Great. This is all of the different parts of the literature library that sort of make up the CPwE. It's constantly evolving as technologies change, as everybody gets more mileage in this world of digital transformation and manufacturing. These are going to be continually kept up to date so that they're relevant and can help people deploy network architectures not only today, but ones that will work into the future as well. All right, great. So just a reminder, we'll send out a slideshow that we're seeing here when we send out the link to the recording. And then in our YouTube video, we'll link the CPwE document down there just so those people can get access to it if they didn't attend this. So I don't see any questions in the chat. We'll give it another minute or so. Thanks for the thumbs up, Tim. And if you guys have any other questions, we're here to help you. We're here to navigate that CPwE with you. So just let us know how we can be of assistance. And Steve, great job. Really good stuff there. Appreciate the time today and appreciate everybody's time on the call.
Thank you, Chad. Thank you for having me. I really appreciate it.
Thank you, Steve.